Yo, what's up, everybody? Welcome back. Today we are working on my debugger, and the topic for today is implementing a virtual machine to look up source files for real this time, unlike yesterday, which was for fake. So, context for this thing is we are writing a debugger, and there's a lot of interesting components of a debugger where right now we are kind of at this state where we can breakpoint at a function and print the variables in that thing. So if we take a simple program and we say it prints, hello world and then some things in a loop and then goodbye, we can run our debugger, and it's very naive right now. He can set breakpoints at these functions with these offsets, and if we run that, then we see on each iteration of the loop, we see, hey, these are local variables, and it found the local variables x and y. It found their variable types as well as their widths and their values. So that's pretty cool. There's a lot that goes into this, right? You need to parse the elf to the executable file to figure out where things are. In there's this bunch of this debug info that is, the further we look into it, the more crazy it gets. And then you use Linux's ptrace syscall to be hey bro, can I look at that guy's memory please? And he's like, okay, sure. And then you're wait, can I modify that guy's memory please? And they're like, yeah, sure thing. So you inject this breakpoint by rewriting the executable as it's running and stuff like that. Pretty fun. But today's topic is right now we have to specify this offset into our function to get these variables to print, because if we were to print them at the beginning of the function, they wouldn't be initialized yet. You'd see garbage values. We want to fix that so that we could maybe either set a breakpoint at a line number, or so that we could maybe step over some instructions or step line by line in that function and then print the variables. Those are a couple of things that we'd want to do. And to do that, we need to parse line information out of the DWARF information, where DWARF is this debugging spec for Linux executables, probably for other executables as well. I don't really know. And this thing is very funny. I think I lost it. We were supposed to be at section 6.2. Here we go. And so the way that this stuff is placed in the executable is they say, look, ideal form would be a matrix of all instructions to all lines. That way you look at the program counter in the executable, you see that you're executing some instruction, and you can look up what line number you're at. We can maybe give an example with GDB. GDB. If we were to set a breakpoint at debuggy do print loop, and we run, and maybe we step a couple times, GDB kind of knows that we're this instruction in the machine code, and he is doing some sort of lookup to say, oh, well, what line is that, right? Wherever we were, it printed out hey, you're at this line. And when you type next, he goes from one line to the next. So it's how's he do that? So he, the ideal world is you have every single instruction here. What line are you? And the spec says, essentially, that's too expensive to hold, right? Why would you do that when you could do something more advanced? And what they do is actually very funny. One is that they remove duplicate lines. Sure, that's reasonable. I think they say that somewhere in here. I'm not sure. I can't read very fast. But then they say, second, we design a byte-coded language for a state machine and store a stream of bytes in the object file instead of a matrix. This language can be much more compact than the matrix. When a consumer of the line number information executes, it must run the state machine to generate the matrix for each compilation unit it is interested in. That's crazy. So they've invented not their own language, but their own essentially machine code that defines how the function, how each line is mapped to each instruction. How does that happen? I don't know. That's what we want to find out today. So yesterday we kind of got to the point where we parsed out the information enough to find this thing. So we kind of got to the point yesterday where we had we have this line program experiment, and we basically get some compilation unit out of the DWARF info. We say hey, where is the statement list for this thing? This goes in this other section of the binary called .debug line. If we do read elf -e, one of the many things in here is a debug line section. We find this thing, and then we figured out how to parse the header for that. So in here somewhere we have we basically read the spec to pull out all of this information. We thought that would be quick. That ended up taking a full stream, so we called it there. And today we are starting basically the next byte out of this stream should be an instruction for our virtual machine to execute. And so the task is, let's figure out how to do that. So I think step one here is probably we probably need to have our virtual machine structure in some way. Calling it a virtual machine might be a little bit aggressive here, but I think it really is a very, very, very rudimentary virtual machine. So I think that we should probably like stub out all of the like registers and stuff that it expects to have. They kind of have definitions of that down here somewhere. Where'd it go? I thought it was, maybe it was above this. Yeah, right here. They kind of have like our default state. So we kind of have to like set this up. Then I think that we will just start trying to run the line program instruction, like program, and just see what we get. And then once we have something that is sane, we should be able to implement like step by line or breakpoint by line. Maybe breakpoint by line is probably a simpler thing to start with. Okay, let's just start moving and see what happens. 0545. All right, so let's start by just copying these fields in the PDF. Copy this, and we'll just put them in struct. Const line program machine is a structure like this. I will also note that normally you would let a library do this for you, but this is more fun. libdwarf, which is the library that we're using to like extract information from the DWARF data in general, does provide this, but I wanted to do it myself because it's more fun. I want to understand this thing. Okay, so I guess these things are going to be fields of this, and I guess we have to like figure out what their types are. So let's see if these are well defined. Program counter value corresponding to the machine instruction. So this is probably U64. Based on this stream title, I assume we're dealing with LNP font. Yeah, I think so. If LNP line number program, yeah. Op index. Unsigned integer representing the index of an operation within a VLU. I don't know what a VLU is, but we'll figure that out. The index of the first operation is 0. This, I assume, doesn't have to be that big. I'm going to start with U32 for now and just kind of see how that goes. File is an unsigned integer indicating the identity of the source file corresponding to the machine instruction. Actually, probably all of these will be U32s. This feels like reasonable enough to me. Unsigned integer. We can always come back and reduce these things if they're wrong or expand them if we start crashing, but we're not really too worried about being robust because this is kind of more of like an exploratory thing. So we will kind of figure this out as we go. Basic block, anything that says false here, I think we can assume is probably a Boolean. Yeah, so bool equals, and then we'll take these like quotes out. I guess probably we can do something like colon bool equals, and then delete this, and then go again. Boom, boom. Love me some Vim macros. ISA is an unsigned integer whose value encodes the applicable instruction set architecture for the current instruction. I assume they're not talking about the ISA. Like, I'm assuming they're not saying that there are multiple instruction sets of the DWARF line program. I'm assuming they're saying that like this is an x86 instruction or this is an x64 instruction. But we will see. And I assume that this can have more than one value. So we'll kind of set this as U32 for now as well. And discriminator. What does that even mean? Discriminator. I feel like I've heard this word. It's like thing between other things, right? One that discriminates. Okay, well that's not good. We are not about discrimination on this channel. But here in computing, discriminator is a field of characters designed to separate certain element from others. Yeah. So like commas in an array. And what is this thing? An unsigned integer identifying the block to which the current instruction belongs. Sure. Okay. I don't know where blocks come from, but we'll figure those out at some point. All right. So now we have to like construct this thing, and we have to construct it with an initial is statement value that comes from the header. So this is, I guess we'll like initialize this with is statement and return a line program machine, and this will just be like a little simple. Think this is like a little silly. Maybe an init function is like not zig-like here. I'm not really sure what people normally do here. I think I've seen like both patterns where like either you can pass these things in as you can make a function that does this, or you can kind of be like, look, bro, you are a programmer. You can read this structure definition. You'll figure out that there's one thing you need to set. Who knows? I'm going to do it this way because that's what makes sense to me right now. Okay, so what are the instructions that we might parse? seems like the next thing to talk about. Special opcodes. These have a ubyte opcode field and no operands. Most of the instructions in a line number program are special opcodes. Okay, interesting. I would think that if most of the instructions are special, that kind of makes them not special, would be my argument. But I could see that maybe these are. Maybe we'll understand a little better in a second. Standard opcodes. These are a ubyte opcode field which may be allowed by 0 or more LEB 120 operands. Okay, except for this. See below. The opcode implies the number of operands and their meanings. Sure. Okay, so we like expect to see like add, and add will have like 2 things next to it, maybe like like a normal program. Extended opcodes. These have a multiple byte format. The first byte is 0. The next bytes are an unsigned LEB 120 integer giving the number of bytes in the instruction itself. I see. The remaining bytes are the instruction itself, which begins with the ubyte extended opcode. Okay, sure. So we've parsed this header already. Let's see what they say about running this bad boy. As stated before, the goal of the line number program is to build a matrix, blah, blah, blah. Within a sequence, addresses may only increase. Sure. So special opcodes. This is what they were talking about earlier. They said most of the things would be these guys. Each ubyte special opcode has the following effect on the state machine. Add a signed integer to the line register. Okay, modify operation pointer by incrementing the address in op index registers as described below. Okay, so what is an operation pointer? Is that stored in this? No. So they say operation index and address are, these somehow are together make an operation pointer, which I assume is the instruction pointer, but we'll see. Append a row to the matrix using the current values of the state machine registers. We are going to not make the matrix, I think, right now. I think we're just going to try to like print out what we see and then maybe later decide to make a matrix out of that. I think that it should be up to the consumer of our library whether or not they want to store that information and how they want to store that. So we probably won't do that. And then it sets all of these things. And so probably it makes sense. Just reading that, it makes sense to do something like handle special op. And then they say each of these takes in a U byte. So maybe this is going to be like op is a U8, right? And key is going to, at the very least, set basic block, prologue end, and epilogue begin. So these guys. So this must take in self by mutable reference because he's going to be modifying his internal state. These go like this, like this, like this. And I think he said set them to false. False, false, false. Discriminator 0. And add a signed integer to line register. We don't know which signed integer yet. Append to, what does he mean as described below? I'm assuming that he means below, not in this list of 7 things. Okay, all of the special opcodes do the same 7 things. They differ from one another only in what values they add to line, address, and OP index registers. Okay, so that's this part. Then here they have kind of, I assume this is like a comment. Instead of assigning fixed meaning to each special opcode, the line number program uses several parameters in the header to configure the instruction set. Oh, I think we saw that yesterday. So there was something like opcode base, line base, something like this. This is going to probably be relevant. There are 2 reasons for this. Although the opcode space available for special opcodes ranges from 13 through 255, the lower bound may increase if one adds new standard opcodes. Right, okay, that makes sense. So there are like 13 reserve numbers and then everything else is like fair game. But if for whatever reason in the future there is a new special, it's weird because the special ones aren't special. If there's a new standard opcode, then that could bump the 13 up. That makes sense. So they're kind of like provisioning for extensions to this thing without having to update. So I guess they're trying to say like maybe in DWARF 5 we have a new instruction that we want to handle, and we don't want DWARF 4 programs to fall over in that case. Maybe it's sane for them to just skip them if like maybe they want to like design it that way. Okay. Thus, the opcode field of the line number program header gives the value of this first special opcode. Second, the best choice of special opcode meanings depends on the target architecture. For example, for a RISC machine where the compiler generated code interleaves instructions with different lines to schedule a pipeline, it is important to be able to add a negative value to the line register. Ah, okay. To express the fact that a later instruction may have been omitted for an earlier source line. Okay. For a machine where pipeline scheduling never occurs, it is advantageous to trade away the ability to decrease line register in the return for the ability to add larger positive values. I see. That's very interesting. So they're saying like in some architectures we want to go backwards, and some you never want to go backwards, and so you want to be able to exploit that, both of those things, and so you allow that by extra fields in the header. Okay, sure, whatever. Special opcode value is chosen based on the amount it needs to be added to the line. On the amount that needs to be added to the line. Address and OP registers. Okay, the maximum line increment for a special opcode is the value of the line-based field in the header. This guy. That is the maximum line increment. Plus the value of the line range field -1. Oh, okay. Line base plus line range -1. If the desired increment is greater than the maximum line increment, a standard opcode must be used instead of the special one. Okay, sure. So, right, because those standard opcodes had like variable width integers as arguments. So you could be like, if you want to jump like, 300 lines and you can't fit that in a U8, then you go like, okay, we'll use this like standard opcode and say, jump big amount of lines, please, man, followed by 300. That makes sense. This is how they define it. I kind of assume that they also are going to tell us how to reverse this, that we don't have to do ourselves. To decode a special opcode, perfect, because then we don't have to think. So adjusted opcode is this minus that. So I guess that means that our machine, when he calls this handle special op, he needs this opcode base and line range. These are two, and maximum operations per instruction. Okay, yeah, so we need to kind of store these like external things. So maybe we'll kind of put all of this as like a, it might make sense to put this in like a nested struct that's like state, because then it'll be clear to us when we're like working with this stuff what is kind of like external and what is like internal. And then we can have like, maybe we just store the whole header here. Maybe we just say like, hey, let's just keep one of these guys around. And so now this like, now we can say header is a const line program header 32, and this gets header is equal to header, boom. And then here we have a state is equal to this. Okay, all right. So now we can kind of just do what they're saying. Desired line increment minus line base. How do we get, oh, sorry, wrong way. Adjusted this way. Adjusted opcode is equal to op minus self header opcode base. Okay, we're chilling there. Then the operation advance is equal to the adjusted opcode over line range. Now, what is not clear to me here is if this is supposed to be integer math. I assume so. I assume this is supposed to be integer math. In which case, this is a truncating divide, I assume. New address is equal to self state address plus the header minimum instruction length. Oh, interesting. So they're kind of doing like a minimum instruction length is like, why store big numbers when small number do trick, right? So if you're like our instruction set always takes 4-byte instructions. Then like, why would we ever waste 2 bits on storing 0, 1, and 2, and 3? Instead, you just say, okay, we'll consider 4-byte movement 0, and we'll add in this minimum instruction length, which makes sense. Times the op index plus operation advance over the maximum operations per instruction. Is this a lerp? It might be. So here we look at our existing op index, I guess. Okay, what the fuck is that? What is happening here? I can't even tell what these addresses and op indexes like indicate. So here they're saying that the new address is how much we've moved forward in operations over maximum operations per instruction. So let's see, if this is integer division, that means that this will always be 0 or 1, or maybe it could be like, it could be more than 1. There's no kind of guarantee in that. So I think what I'm kind of seeing here is that you have like address is like your top level, and then each address has like maybe more than one operation, right? And so they're kind of saying that they're allowing us to index into these subfields, and this operation advance field is telling us how much to advance these. And they're assuming that like if the maximum was like 10, right? Then if this thing only does 3 things, then the operation advance is like 7 to get to the next address. And it's kind of indicating to me that they're kind of saying like you might be able to jump like several addresses at once. I don't know if that's something that you would do, but maybe it is. Okay, sure. So then the question is, I think that this is integer math. They're saying that like we have gone over 1, we've gone like 0, 1, or 2 addresses into the future, and then the amount that we have gone into that new address is kind of like handled by this next thing. That's how it looks to me. And so I'm going to work under that instruction, like that, that assumption for now. So I'm going to name this something like num const address advance. Okay, this is op index plus operation advance, which we have. So this is header, no, state op index plus operation advance divided by maximum. Wait, okay, so if all of this is getting multiplied by minimum instruction length, they're kind of saying, I thought this was plus. Oh, yeah, okay. So they're saying, did we finish an instruction? Did we finish an instruction? Op index is indicating how many instructions we've finished. Yeah. So it's instruction. It's like address. I'm missing a piece here where. What if you have like variable address instructions? Sorry, variable width instructions, right? Like if we do obj-d on this guy, right? Some of the instructions are 2, right? Some of these things are like 8 or 7, right? And so how does this kind of account for that? Doesn't feel clear to me. I guess if everything is a multiple of the minimum instruction length, then this does make sense. But maybe they're not all multiples of the minimum instruction length, right? What if you have 2, 3, and 4? How do you represent 3 by this, right? In which case, this would have to be floating point, all of this, but I find that kind of hard to believe. Maybe minimum instruction length gets like set by the compiler to be like the least common multiple instead. Maybe. I guess we will kind of just do it as integer math for now and put like a fix me, is this supposed to be floating point math? If we had minimum, oh, this is over maximum. Minimum times the amount out of maximum? So if this is like, say we have, 8 and 1. We're saying 1 times the amount, oh, this is operations per instruction. Fuck. I keep forgetting. I'm getting operations and instructions mixed up. Okay. Yeah, let's just say, so imagine a minimum instruction size 2, and we wanted to move 3 bytes over. Is that possible with integer division? No. Is that valid DWARF? I don't know. I'm not sure. But we will do integer math for now. Okay. Okay, sure. So this is going to be the like const. This is called operation advance. So this is like instruction advance, kind of. Yeah. And maybe we'll do like a little one of these tricks where we do instruction advance is the header minimum instruction length. Then we say instruction advance times equals this. And sure. Then new address is equal to the old address plus instruction advance. Okay. Now we need to get the new op index, which makes way more sense to me, right? This is just op index plus operation advance percent self header maximum operations per instruction. Probably there's like a way for you to do this calculation. Is there like div mod? Is there not? I know that there's like a div mod instruction in x86. Whatever. I'm sure that the compiler will probably figure this out all by itself. All by itself. Okay. So I think this is probably it. Okay, when the maximum operations per instruction field is 1, op index is always 0, and these calculations simplify. Oh, interesting. The amount to increment the line register is the line base plus the amount of adjusted, plus the result of the adjusted opcode modulo the line range. Okay. Line increment is equal to line base plus adjusted opcode percent the header line range. Okay. And this should be line base, I think, is in the header. No. State. Yeah. Although I think that the header also had a line base, which is confusing. So we have a line base register, I'm pretty sure. No, we don't. So why did I think we do? Because the indexer wasn't mad at me, but I feel like it should have been. But that's okay. Okay, as an example, suppose that opcode base is 13, line base is -3, line range is 12. Okay, minimum instruction length is 1, and maximum operations per instruction is 1. This means that we can use a special opcode whenever 2 successive rows in the matrix have source line numbers differing by any value within the range 3 and 8. -3 and 8. Okay. Oh, I see. So if we want to advance 1 line and 0 operations, then we write 17. And these are all unique numbers. I see. I see. Okay. Okay, sure. Sure. So then we can just kind of say that here we probably just want to assign at the end self state address is equal to new address. Self state op index is equal to new op index. And self state line is plus equals line increment, it sounds like. Maybe we do this is equal to instruction advance. That feels nicer to me. Sure. The rest feels fine. And then all this has to go into state as well. All right, so that explains what a special opcode is. Now, we probably need to handle these standard opcodes as well. However, since it said that the vast majority of these things are special opcodes, we should probably be able to like start iterating the program in some way. So maybe we're gonna do like feed. How do we want to do this? maybe here we're gonna kind of structure this thing as an iterator. And he is going to like, maybe he's not going to output anything, right? Maybe he's just going to basically like indicate that he's not done yet. So then you can do while, maybe we'll call this step. Step feels more like I'm moving an algorithm forward instead of I am getting some amount of output. So then this will let me do like while step externally, which feels kind of good to me. And then here we'll just say this must take in some sort of like reader, right? Where are we getting the data from? And then we're just gonna say like reader, read byte. I'm assuming is on here. It's gonna be hard. Maybe we could do like std io reader. Can we like, I guess if I just write any reader here, then we'll get everything we want, and then we can switch it to any type later. So read byte is in fact valid. This has to fail, or sorry, it doesn't have to fail, but it has to have the option of failing if he wants to. And this is going to be an operation, right? And then we are going to basically check if op is above self header opcode base, right? That's what they said. Opcode base is the first special instruction. The number assigned to the first special opcode, so assigned to the first one, so greater than or equal to. We say handle special op, else panic unimplemented. All right, so now that we've parsed the header, we should be able to construct our line program. Line program machine initialized with our header as well as our reader. And here, what happens next? We have var LPM, I guess, and it'll say while LPM.next with our reader. Wait, if this is not initialized with the reader, I'm an idiot. He's initialized with is statement, which actually doesn't have to happen anymore. This comes from a header is statement. Okay. Then here we don't pass in the reader. The reader comes in on next. Because I felt like it. Okay. Step, sorry. And now we're gonna replace this with an any type. And let's see if we can build this thing. Okay, non-void return type, that's true. It's a really good point. We'll just return true unconditionally, because I don't really know how to tell for at the end yet. And expected type bool found U8, so default, here we're just gonna say like is greater than 0. Expected U8 found U32 at 936. So op index is U32. Instruction advance, oh, here we just write U32 here. I8 and U8, 939 or something. Line base is an I8. So I think line increment has to be a line, has to be U32, but line increment could be anything. Could be anything, right? So how do I want to represent this? It's easier to do this probably as line is an I32. I think that's just easier because then line increment could be an I32, which means that this can be like as I32 like this. And I think that will compile. Nice. And let's look at dwarf test and just see what happens. So I guess we just get panic unimplemented. That makes sense. It'd be nice to maybe print some state about this thing as we go. So maybe at each step here, we look at lpm.state.address. Yeah, let's do this. We'll look at like this address goes to this file line. I think that makes sense. So then we'll say LPM state address, state file, and state line, and we'll just kind of see what that looks like. What the fuck are you talking about? I can't tell if this is an ad for like a service or if you're just saying that you want to type in chat. Hi. Can I keep you company in your difficult tasks? I will carefully write obscenities in the chat and provoke you if you're ready, then approve your new follower with like. First of all, what do you mean with a like? I can't like anything. Is this like, are you trying to do like for like? This is just very confusing. I guess if you're trying to provoke me, you've like immediately succeeded on message one, but it's just confusing. I'm not gonna ban you because I'm not sure that you're a bot, but it's like it seems so bot like, you know. Okay, let's see. Maybe we will print the opcode initially. Std debug print got op d. And maybe we are off rip hitting a standard opcode. Yeah, 4 is definitely standard. So let's start looking at standard opcodes. This is interesting. Seems like we are probably going to have to ask this thing for his opcode length. But let's see. Okay. So can we look up like let's take a single unsigned LEB 120 operand and stores it in the file register of the state machine. So are these like defined somewhere? Yeah, they are. So these are the instructions here, I guess. So we kind of just, whoop. Why can I not copy this? Oh my god, fuck tables, man. Can I at least, oh my god, I'm gonna lose it, I'm gonna lose it, I'm gonna lose it, I'm gonna lose it. You're gonna make me you're gonna make me type these with my fingers like a fucking pleb? Oh dude, I'm gonna lose it. I'm actually, okay, fine. We're just gonna type with my hand. I would like to enter low-level world starting with Zig, but this is just too much for web backend dev, lol. Well, I hope that I can explain things as I go better to the point where it's not a problem. But I understand if you're like, fuck this. But maybe if you stick around, you might get something up. Because nothing we're doing is that crazy complicated. We're kind of just reading the spec and following what they say. Okay, so I guess we'll call this DW DWARF line. What does LNS stand for, do you think? Line number statement. I'm just going to call it LNS because I don't know. Okay. So we had, I guess we'll just fucking use our fingers like fucking losers. Copy equals 0x01. Advance PC is equals 0x02. Advance line is equals 0x03. Set file is equals 0x04. Set column. Can we just maybe negate statement? Set basic block. Const add program counter. Fixed advance program counter. Okay. Set prolog end. Okay. And there's one more. Set epilogue begin. And set ISA. Okay. All right. So this is just going to be, I think they just monotonically increment 5, 6, 7, 8, 9, 10, 11, 12. Okay, I don't know why we're doing this in fucking hex. So I think that you can just do this, right? And then everything else just kind of auto increments for free. And then this is probably U8 repper. Right, I assume that this is going to follow the same pattern as C, where this becomes 2. I assume. So can we do enum from int? Does this panic on failure? Undefined behavior. So here we probably want std meta enum int int to enum. Yeah, here we go. And then this will check the bounds. So here we will set this to DWARF LNS. I think this was defined instead DWARF LNS. Oops. Oh well. That's okay. We'll live. So we will say that this may fail, and if this fails, we'll just say catch, and we'll panic unknown opcode. I mean, in reality, just return an error, really. Panicking is bad. Unknown op. Okay? And then here, this is the standard op, right? And then we switch on the standard op, and we do something with them. So for now, we'll just write else return error unhandled op, and then we will std log error unhandled opcode with this 0x this number, and then hopefully, oh no, this is a string actually, a string. Look at us, and we're gonna do enum. What is it? Tag name. Yeah, here we go. Standard op. All right. Oh, DWARF VM, good memories. Hi everyone. Hello. Unhandled op set file. Okay, that makes sense. Let's start there. Set file. What the fuck does this guy do? Takes a single unsigned LEB 128 operand and stores it in the file register of the state machine. So here we should just be able to do set file. And that's what we call it, right? So he just does like std LEB read an unsigned LEB 128 from the reader. And this is gonna be file is equal to this. I assume that this can fail. Yep. Try that. And if that does not fail, then we just have self state file is equal to file. Boom. Simple. He needs to know what we were reading into, so I guess we will read into a U32 for now. I guess even now we can go type of self state file to get kind of crazy with it in case we change it later, change our minds later, you know. Invalid something. Oh, is type of probably has a capital T because it's returning a type. Okay, now he's on set column. All right. Same shit. Same shit. Set column. It's just now column is this. Boom. All right. Okay. So we got op4. We are at address 0 at file 5, line 1. Got 5. And we're still at file 5, line 1. Got op10. And we need to say set prolog end. What does that do? I guess also kind of at some point we started doing this. Now, this was at some point before now. This takes no operands and it says the program prolog end register true. Okay, what does that do? When a breakpoint is set on entry to a function, it is generally desirable for execution to be suspended not on the very first instruction of the function, but rather at the point after the function's frame has been set up. Yeah, I agree with that. After any language-defined local declaration processing has been completed and before execution of the first statement of the function begins, debuggers generally cannot properly determine where this point is. This command allows the compiler to communicate that location to use. Okay. Sure. Oh, I see. So we can we could theoretically look for the first instruction after the program, after the function start point that this register is set to true. That makes sense to me. Okay. So set prolog end, and this is just self state prolog end is equal to true. So I assume that there's going to be a clear prolog end somewhere that we don't have. Got op 0. That's an unknown operation. That's interesting. What does that mean? What does that mean? That means that either we did some incorrect parsing or that this is like a sentinel value that means something. Let's see. So where were they telling us about special opcodes? I assume that it's going to be in the same area. Okay, special opcodes. So 6.2.5.1.2. I mean, is there 0.3 after this? Extended opcodes. Is there like a 0 in here anywhere? Okay. Each U byte, special opcode, blah, blah, blah. Line number program. Line number is within a sequence of addresses, blah, 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 can only increase. Somewhere in here, they must tell us if there's a special ISA value 0. Oh, this is ISA. This is not what we want. Okay. State machine registers, definitions. Look for like 0. This 0 is very unhelpful for searching. Because I know that I saw that like there are special values of 0 for some of the other fields. Like the file index, for example, or the directory index maybe was the one I'm thinking of. But this is kind of none of those. When I implemented this, I looked at the GCC source code. I thought it was easier. That's fair. I think that there's probably stuff missing from here as well. I would like... Oh, here. No, index is 0. Fuck. Maybe it's one of these. Can we look at like DWLNE and sequence and stuff? Like, where is this defined? Yeah, this is all 0 as well, or 1, 2, 3, 1, 2, 3. Wait. Boolean. Oh, this is 0 for false. Sure. The version number in the line program header is 4. The encodings given in figure 37, which is just this. Okay, can we look up, like, maybe we will just ask that idiot, ChatGPT, what does line program opcode 0 mean in whatever the fuck we're working on? DWARF line and DWARF line programs. Maybe he'll tell us. It is a special instruction known as the extended op instruction. Well, we'll check if that's true. Extended opcodes. Oh, I think we did see that actually, huh? The first byte is 0, the next byte are an unsigned LEB 128 integer given the number of bytes in the instruction itself. Does not include the first 0 byte or the size. The remaining bytes are the instruction itself, which begins with a U byte. Okay, so maybe for now, we will say else if op is equal to 0, we can do something like what? Oh, this needs this here. I guess we will read an LEB 128 for the extended opcode length. And then for now, can we just like reader, is there like a skip bytes? Yeah. Like, can we just do this for now? So here we'll say stood log warn unhandled extended op this. I guess they're listing them in hex in the spec. And then we'll say skipping. Boom. And hopefully this just is important. Surely it's not, right? Then we take extended. Oh, we don't even know the code here. We could do, wait, it said the length is not including the opcode. First byte is 0, the next bytes are an LEB 128 integer, giving it a number of bytes. It does not include the first 0 byte or the size. Okay, so it does include the instruction. So let's read 1 byte to get the instruction. This, and then we can log the extended op, and then continue on. Let's see what that does for us. Unhandled extended op, 0x2. So what is that? That was LNE for extended, probably. Yeah. So these line number extended opcodes, sure. So set address takes a single relocatable address as an operand. The size of the operand is the size of an address on the target machine. It sets the address register to the... Okay, that sounds just like important. Right? So surely this is like... Why even call this... What does extended even mean? I guess that just means that they're like extended in terms of like how many bytes that they are in the machine, not like that they're like an extension to the protocol. So I guess we do need to handle these. So DWLNE. Where are the fucking... Here. End sequence, set address. Can we like just put this here for a second? So DWARF LNE. So we have end sequence, set address, define file, set discriminator, hello user, and hi user. Hi user. All right. So here we're gonna kind of do the same thing where we get like the extended op is a extended op raw, we'll call this. Then we have extended op comes from extended op raw. So we get we got the U8 out, we turn it into an enum, and then we can put this as a nice little string. So this is a tag name from extended op. Extended op. Okay, which means that now I guess here we are just going to switch on extended op. I don't really know why this extended op len needs to exist, because I assume that like the following parameters are going to define what happens, but maybe we'll put a fix me validate red bytes is equal to extended op len. We'll kind of do that later. So on set address, we're gonna have to do something, but on else, we're gonna just return an error here. Unhandled op again, and here we're gonna say this. Bum, bum, bum. Bum, bum, bum. All right, seems reasonable to me. Set address, we do have to do a thing there. So LNE set address says that we take a single relocatable address as an operand. The size of the operand is the size of an address. It sets the address register to the value given. So like, what the fuck? Hear me out. What the fuck is a relocatable address? Like, I understand the concept that like you have, you have like lib stuff.so, right? And I understand that like in here, like all of you compile this thing with f position independent code to tell the compiler like, hey, don't like hard code addresses for this stuff, right? Like instead, could you maybe like, just like say go back 50 instructions and call that instead of saying like go to this specific address, because that way this can go into like any location memory, right? The LD, you're like ld.so when you launch your executable is going to like look for all the dependencies that your binary has. He's going to be like, take lib stuff, and I'm going to just like stick that at like zero, like some memory address, 0x1000. Right? This is where it won't be 1000. It'll be something way bigger than that. But like, bear with me. I think that actually, while we're here, I think that like Linux kernel reserves either the upper half of memory or the lower half of memory. And then I can't remember. I think that like this 0x below some address feels like something that just never hit to me, but maybe I'm just like making that shit up. Seems possible as well. I don't remember. But so this, like, I kind of understand this concept that if you were like, I want to breakpoint at like a function in lib stuff, function stuff. Like, in order to breakpoint on this, you need to like say that this is some address relative to this loaded address, and your debugger needs to discover, like, say, okay, I know that I'm in lib stuff, and I'm going to look at that, but I just don't know, like, in this context, what does it mean? I guess that it would probably just mean that, like, probably, maybe, which compilation unit you're in, and which compilation units belong to which shared objects. I guess when you are parsing ELF data, you parse, I would assume, you actually parse the shared objects independently of each other. So the relocatable part probably actually is irrelevant here because externally that every address in here is going to be relative to the base address of that shared object. I think that makes sense. And I guess it's not only for shared objects. I think that is this what like ASLR is? Linux ASLR. Where like they say like address space layout randomization, where like you kind of like just throw shit at random spots and you can like compile your binaries as fpic as well or something. I don't know what the fuck I'm talking about. Can ask, what did you do as your job before switching to streaming? Yeah, I've got this question a few times, but I'll answer it. This will be the one time I answer today. I've worked as a embedded programmer in like security cameras, where we worked on like guy gives you like board and he says like, here is board, could you make it do stuff? And then like guy in mechanical says like, here is this lens that we want to attach to this port on that board, can you make it do stuff? And so you have like a little bit of microcontroller programming, not a lot of that, mostly like user space Linux stuff, to do like control this stepper motor. I guess like stepper motor stuff was on microcontrollers. Linux would be like, talk to that microcontroller over I2C and ask it to do these things for you, or like pull images off this like digital signal processor and like drop them into H.264 packets, stuff like that. I guess they came out as H.264 packetized somewhat, so you had to be like configure that thing and then like put them into like a TCP stream, stuff like that. And like our job was like mostly like lots of new cameras all the time, big code base, try to adapt code base to new camera. Usually it doesn't fit one-to-one, stuff like that. And then I also worked at this like neural network. I'm not supposed to call them that probably. I think that they want to be called robotics solutions company. So like manufacturing robots, pick stuff up, attach car door to car. How do I know where car door is? Or like build car door. I have screws in a bucket. I want to pick up screw at this like specific orientation so that I know how to like stick it in this hole over here. Like, how do I take two cameras and find everything in a box related to that? Relocation needs PIE, PIC. How do I don't think it needs ASLR. Okay, makes sense. Makes sense. Okay, so I think we can just assume that this just sets the address field to the value given by the relocatable address and sets it up index register 0. Okay. But I will also say that I don't know how much my previous job experience impacted the, like, if you're asking like, how did I get this type of knowledge? That actually has nothing to do with previous job experience as much as it has to do with just like always trying to poke stuff. I guess one of the jobs really pushed towards like root causing. I guess they both did. Like really like understanding the root of a problem, and so that kind of helped. But in reality, I don't really know. I don't really think that the jobs are why you're seeing what you're seeing right now by whatever you're looking by some metric of what you're seeing. Okay. So is that all this thing did? Set address to relocatable address that is a single oh wait, does it say that it's LEB 128 or did I just assume that? do other guys say LEB 128? Yeah, like this guy talks about LEB 128. So set address opcode takes a single relocatable address as an operand. The size of the operand is the size of the address on the target machine. Oh, okay. So this is just like a fucking like U64 or something. So I guess that here we actually do want to look at the extended oplen here. And we want to like std debug assert that the extended oplen is equal to 1 plus the, we are assuming 8 bytes here. And here we're going to be like 1 byte op and 8 bytes pointer. Okay. So this is going to be and here we're saying assuming 64-bit machine, invalid assumption, but good enough for me for now. Okay. All right. So the address is now just like reader read all into some buffer. Std mem as bytes. Can we just do like actually like this? Is this crazy? Yeah, that is crazy. Let's just do var at new address is a U64 equal undefined. Is this legal? I can do it this way, right? Just like read it like fucking directly into that shit. I think this goes like here, and then this we write like try on this, and this gets a new address. Okay. He's mad because stdlog error, expected pointer dereference, optional unwrap or field access found error, because extended op must be, I forgot to write. What is the type of this? DWARF LNS? So wait, what the fuck is the problem? Tag name of extended, what the fuck is he bitching about? It was fine down here. Expected, what is he complaining about? What a weird error. Expected pointer dereference, optional unwrap, or field access found error. Oh, I'm an idiot. It's error. Confusing error, because error is a reserved keyword. Okay, no field set address on LNS. Because this should be an LES. Did we not? Oh, LNE. Sorry. Extend it. And then use size is ignored. So here we want to say const read bytes. I fucking hate that read and read are the same fucking spelling. That gets me so often. And I guess we'll say if read bytes is not equal to 8, or even we can get even crazier, size of new address. We can say return error unexpected EOF. Fine. Expected type is as bytes is supposed to do pointers a single item. Yep. Okay. Expected U32 found U64. I guess this should just be a U64. I think that makes sense. Okay. Advanced line. Unhandled op advanced line. You know, for a spec that says most things will not be standard, there sure are a lot of standard. Advanced line. Takes a single signed LEB 128 operand that adds the value to the line register of the state machine. Okay. Sure. So this is just advance is equal to the thing we're adding to line. And then wait, is line a signed integer? It is. But this signed LEB 128. We gotta be careful with that. What is the ULEB and there's ILEB. I for unsigned. I for signed. Okay. Line and line. Advance. Seems straightforward to me so far. All right. So it would be kind of interesting. I wonder if we can look up what files these are, because we could actually start trying to like correlate how fucking batshit this stuff is. So we could look at header file names, and I think that this is -1. Let's look. I can't remember. Maybe directories was the one that was off by 1, and files was not, because include directories. The line number program assigns numbers to each of the file entries in order beginning with 1, because the current directory of the compilation is understood to be the 0th entry, which is probably not true for file names. The index is 0 if the file was found in the current directory. Okay, the directory index represents. Right. What about the file? Line number program assigns numbers to each of the file entries in order beginning with 1 and uses those numbers instead of the file names in the file register. So it is still -1, but without an implicit 0 thing. So now here we should be able to put a string here, and let's just kind of look skis. He's mad because file name is actually not a file name. We gotta look at his name as well. File name. So we're kind of looking at like start.zig1, and then he immediately fucking runs it to startzig 265. Now it could be if start.zig is full of like type definitions at the top, that could make sense. So can we maybe look at zig, and we can look at like start zig in here, and let's see what happens between line 1 and 265. This is a comp time block, so nothing. This stuff does do stuff, maybe, but it would be interesting to see. Maybe there's a reason he's skipping all that. Maybe it's not included. 265. So this stuff is probably compiled out. Okay, you know what? There's a good chance that this is right? All of this stuff gets compiled out because it's not for our target architecture. And so this being like the first thing might actually make sense. Well, even this. Oh, I see. So this is kind of weird where the code in here is like how do I say this? Like this switch returns a string that gets fed into this ASM volatile, which makes the ASM volatile the first thing. It'd be interesting to also check. We can see if this is right by looking at the disassembly of our program and see if we can find start.zig in there, right? That'd be a kind of fun little experiment. So you can do like obj-d, and we do see that the first piece of code we see in here is XOR EBP, and then move RSP, RIP, right? So can we go back and look at start.zig and see if that matches up with what we see at this line? XOR EBP, move argv pointer to RSP. So I think that that's a very clear sign that this is, at the very least, we've done something right. That's actually super fucking sick, right? We've got through enough of this program to like get to the first line, and the first line matches up. So we haven't done anything that's like brain dead fucking stupid yet, as far as I can tell. Big win for us. Big win. That's pretty cool. Unhandled op copy. All right, what the fuck does a copy do? Copy. First one. Takes no operands. It appends a row to the matrix using the current values the state machine registers. Then it sets the discriminator register to 0 and sets the basic. Okay. So I'm not going to do that. So we're gonna do copy. So because like I reject the premise that this is supposed to create a matrix. I reject the premise. But we could maybe argue that this could turn into an iterator now, and this should be like where we return a value from iterator. Spec says that copy means copy into matrix. We reject the premise of the matrix. But we could do return from an iterator at this point. All right. But then it also does all this stuff. So can we just be like basic block, prolog end, epilogue begin, registers, and discriminator. Self state dot this equals that. Basic block equals false, prolog end equals false, and epilogue begin equals. Oh my god, it's not a quote, so I can't find the quote because it's like one of these like fucked up quotes. And then these go from self state, and this goes boom, boom, boom. All right. All right. All right, how's it looking now? Okay, so this seems maybe sane so far. He then jumps to start.zig 112. I would like to see what's going on there. So 112 is start 2, call main 2, and if we look at the start code, I bet that we'll see that it's kind of lazily, the Zig compiler must be kind of lazily pulling in functions that are called. So probably if we go past this, are these public functions? No. So how does it know where's start 2 getting invoked? Okay, so if we are building, so if we have no declaration in root start, export start 2, which calls call main 2, which calls exit 2. So actually it's confusing why both of these things are getting involved here, but I'm not gonna get crazy. We're not gonna say that doesn't make sense. I actually don't. I think we're not in stage 2. Right, as far as I understand, we're in stage 3 of the compiler. But what do I know? Right, because they're saying simplified logic is like you kind of like build Zig once to build Zig again to build Zig again or something. I can't remember. Or maybe stage 2 is like the stage 1 is C++, stage 2 is Zig, and then stage 3 is like the final thing or something. I can't fucking remember. Not that I ever knew. But it's saying simplified startup kind of indicates it's like a kind of like a dumb version of the language, right? But I just don't understand why this stuff would be included in the binary at all. But maybe maybe we'll either find out that we did something stupid and dumb, or it's fine. I don't know. Who knows what we'll find out. So this, what was the thing that's broken now? Const add PC. This takes no operands. It advances the address and op index registers by the increments corresponding to special opcode 255. Why? When the line number program needs to advance the address by a small amount, it can use a single special opcode which occupies a single byte. When it needs to advance the address by up to twice the range of the last special opcode, it can use this followed by a special opcode for a total of 2 bytes. Ah, interesting. Is stage 3 Zig without LVM? I think that all Zig builds at the version of Zig I'm using are using LLVM, but I think that there is some work being done for them to make LLVM an optional dependency that will be on for the vast majority of optimized builds, but maybe not for unoptimized. Okay, so this opcode makes sense. Sure. So we're gonna have where the fuck this is like before set prolog end. This is called const add PC. And this is just like self state address plus equals 255, right? Is what they said. And then self state op index is equal to 0, I think. Reset both these. Maybe. It advances address and op index registers by the increments corresponding to special opcode 255. Oh. No, I'm confused again, because 255 is a valid special opcode. When the line number program needs to advance the address by a small amount, it can use a single special opcode, which occupies a single byte. When it needs to advance the address by up to twice the range of the last special opcode, it can use this, followed by a special opcode for a total of 2 bytes. Only if it needs to advance the address by more than twice will it use both advanced PC and a special opcode requiring 3 or more bytes. But I don't understand, if it's equal corresponding to special opcode 255, why wouldn't it just be 255? You know? I'm a little confused by that. But whatever. We will see if that makes sense. So got op, this was 8. So here we went from 112 to 355. And is that a reasonable thing for him to do? Kind of not really. Oh, but also, am I on like the right version of Zig? I am. I'm on 0.13.0, which is what we're using. So, I mean, it's not maybe like completely unreasonable, right? Like there is a function here that maybe is getting compiled in for some reason, and like that I don't understand, but then there's no code generated with it. Just debug information gets generated, and then they go like, oh, but like, how about we just immediately fucking run it again? Or maybe that's just part of a sequence here to get to 571. Oh, this does not look right. This does not look right at all. It feels like we've made a mistake somewhere. It feels like a mistake. But I don't really understand why. It advances the address and OP index registers by the increments corresponding to special opcode 255. Okay, so can we look at that matrix again? So 255 is very much like a thing that is there. And so if this is 1 byte and this is 1 byte, I really don't understand why this exists, which means that like I must be misunderstanding it. But also like, but then like this is so clear. This feels so clear that this is what it's saying it does, that like it can't be wrong. Right? It's also possible that we got something else wrong before that case. Maybe we keep going, and if we just keep implementing stuff, we'll kind of end up in a case where we can parse some of our like if we don't crash, then eventually we'll make it to like a file we wrote, and maybe we will understand that a little better. But something about this doesn't feel right. In fact, could we I'm not sure. If there would be, it would be nice if there's a way to like inspect the output of this thing from somewhere else, but fuck it. Fuck it. Advanced PC. Takes a single LEB 128 operand and modifies the address and op index as specified here. What? This okay, so this takes a single LEB 120 operand as the operation advance and modifies the address and op index registers as specified here. So it's just like your special, it's just like give me a special opcode that's big as fuck is what I'm reading here. Right, they're kind of saying like just keep doing this same table but for bigger numbers. I think that's what it says. But you know, I could be wrong. I'm wrong a lot. We are going to have to think about at some point how to debug this a little better. But that's okay. So we're gonna be like val, and then we're gonna be like self handle special op of val, which means that handle special op kind of needs to allow us to take kind of like any type. I think. And then this needs to be an unsigned. My bad. And let's see if that compiles. So, oh, here we also probably want to take in this thing as like a U32 or something. So expected type I32 found U32 in adjusted opcode. So before we had U8 minus opcode base, which was also U8. Now we're doing U32 minus U8, which seems fine. Self-header line range is a U8, so this should be U32 over U8, which also seems like it should be fine. He actually thinks it's a I32, which is confusing to me. I don't really see who... Maybe here we need to do as U8 for this to work okay. I don't understand where this is coming from. 1078. Oh, that's not helpful. Not helpful at all. Reference by step anon at 1025. Here. So this is coming from this, but this is, I don't understand how this could be a I32 at all. It feels like it's confused. Oh, expected I32 found U32. Oh, because it says as I32 there. I'm a fucking dumbass. No, wait. Who says as I32? Line increment at 964. Ah. So adjusted opcode. Oh, so before this probably worked because all U8s can be represented by an I32, but all U32s can't. So can we just read this as a U31 and that should fix the problem? Hell yeah, baby. And here we'll just note line opcode goes to line number in some way. Line numbers are I32s, so we limit the bit width of the red LEB 128 value to ensure all values can be represented in a I32 to simplify future downstream math. There we go. There we go. Hey, if someone gave you a LeetCode medium, I don't know what the fuck that means. How fast could you solve it? Who fucking knows? I hate LeetCode so much, but I'm wondering how fast people actually make so far. So my rule, which is a bad rule, do not follow my rule, okay? But my rule is that I don't prepare for interviews, and so I don't do LeetCode. Because I'm an idiot. But my argument to myself is that I feel like one of my biggest pieces of value that I can provide to someone is the ability to figure something out without understanding it before. So I kind of feel like the more I prepare, the bigger of a disservice I do to myself to let that shine through. But I think that's just wrong. I think that what most people do is they study the fuck out of problems that might be asked in an interview, and then they pretend that they didn't. And I think that that's probably better. But yeah, so I don't know. I've never done LeetCode. And I don't know what the levels are. But you know, I think that's kind of like the thing where you're just like, if you're rich and you're just like, I don't think about making money because there's always money around. Like, I don't know. I might be just kind of like, I don't think about getting jobs because I've like just happened to be blessed with getting jobs before. It's like, I don't know if I, you know, not very good advice. This sets the is statement register of the state machine to the logical negation of its current value. Sure. So state.is statement equals not self state is statement. That's pretty hard for us to fuck up. Set epilogue. Okay, so guys, you think there's a chance that we did something wrong? I think there's a chance, because I don't think that we should ever be looking at debuggy.zig line negative 459, right? I think that that's probably not good. Maybe. Okay, so I think that I kind of want to pause here on implementing stuff and maybe do some sort of debugging here. So I would like to know got op4, got op5, got op3. What are these again? It would be kind of nice if we printed out the names of these things, right? So maybe we'll say got special op here. Here we'll say got extended op by name. Which didn't we do this somewhere? Only on errors. Sure. And maybe we do like std log debug, because surely this will be useful information in the future. And then here we'll do std log debug got standard op s. And this is tag name of standard op. Okay. Let's figure out what the fuck we did wrong. I guess we don't need new lines on our std log debugs, but I wonder if it strips them out for us. That'd be kind of nice. Okay, so here we get set file, set column, and advanced line. So interestingly, they don't call like a hard set line, right? They call advanced line when we get to the beginning of a new file, which kind of indicates that here we were probably supposed to be at whatever, like either we're parsing advanced line wrong, which is very likely, or it's that you know, we were just fucking up everywhere. So kind of what I was hoping that we would get like a hard reset line at the beginning of a new file, but it's clear that that's not true, which sucks. So surely we're just kind of fucked all over the place, and we have to figure out where it gets really bad, where it starts to make no sense. And it would be nice, I would like to, no, I mean, it would be nice to compare with something, but I guess that's kind of cheating anyways, so it's fine. Okay, so I think that we thought that const add PC was a little wacky. I think we go back to our other page and we go to start.zig, and we just kind of start like walking around. We just kind of follow it from the start to the end. And we just try to see where it starts seeing stupid. So start.zig 111, totally reasonable. They call set address. It goes to start.zig 1. We advance line to start 265, which we determined when we looked at the ob jump was reasonable. Arguably, this should be 266. You could at least run it in GDB and figure out the correct line numbers you should be jumping to. Like how? If I do zig out bin debuggy, what do I get out of here? Right? Because like here we need to figure out, like, I guess if I set a breakpoint somewhere, I might be able to figure out like what line that turns into. Right, so we could set a breakpoint at start and hit run. Right? And here he says 266. We saw 265. So that's kind of like maybe something wrong. Shouldn't advanced line add the line and not set it? That seems possible. And adds that value. Yeah, it's crazy that you could find that. I'm shocked that you saw that. Like, yeah, it's crazy that you noticed that. Congrats, like, good shit. Okay, so that makes this advanced line end up in the right spot, which is good, right? rbreak file dot. What the fuck does that do? Oh, it kind of sets like it's saying like where is the first line in DWARF, in the DWARF stuff, but we can probably figure that out ourselves if we look at let's see, debuggy here we can kind of assume that the first thing that it will log is do print loop. I guess we don't really know that. We should probably look here and look for do print loop and see if that's the first thing from debuggy in here. Maybe we do debuggy dot. And it looks like the first thing that actually gets called is debuggy.main would be my guess here. And then we get debuggy print anon, do print loop. Yeah, so the first thing we get is main. So the first thing we see in here should be line 23 or 24 would be my guess. And let's see what we get now. Start.zig, debug. Okay, so this is clearly fucking wrong. We've done something wrong again. Something wrong again for sure. And let's just try to go back to the beginning and see where it starts to go off the rails. So now at the very least we go advance 266, set column 378. Okay, let's see at 378 where that looks like. POSIX call main and exit seems a lot more sane. So here, right, we could probably guess that the ASM volatile 266, he goes in here, he goes into POSIX call main and exit, and that gets immediately set next in the output, which we can do with we can check with an obj dump -d. And the next thing is POSIX call main and exit. So we are in a much better state now than we were a second ago. So 378 is a reasonable spot here because 378 is where that thing is. Then he goes to 621, which is Noop signal handler. So the question is Noop signal handler the next thing that we see in this disassembly? Let's just kind of keep scrolling, just keep scrolling. The next thing we see is debugging main. But let's kind of see. So this gets assigned here for sure. So Noop sig handler. This is here. Right after attach segfault handler. Something about that feels wrong, but I guess we don't have any guarantee that the DWARF info is stored in the same order as functions in the file. I guess we actually don't know that. We've kind of just been assuming that. Or it could be that since we might go back and forth between files here. So here, if we go full screen here, right, we kind of see that it calls start, then start POSIX call main and exit, right, which is in start.zig. But then we go into, sorry, I got lost here. Forward. We go into debuggy.main. So we actually switch files here way before everything in start is finished, which is kind of interesting. Then we go into debug.printanon. So maybe we actually want to look for the next thing in start dot after POSIX call main. And maybe that will be the next thing. Expand stack size. All right. So this is at 441. So there's maybe something to look at there. However, we've been we know that like advanced line at least did the right thing the first time. So maybe we shouldn't get too ahead of ourselves. RBreak will set a breakpoint on all functions. I see. I'm not really sure that that helps me. I don't really see how that gives me extra info, but maybe. Okay, let's look at 621. Noop sig handler. And then we go to 837, which definitely doesn't exist. So my suspicion is that const add PC is doing something wrong and was supposed to go like, I don't know where. Maybe to expand stack size. Oh, yeah, wait. Because where's the next copy? Where is the next copy? We get one copy here, which is like, yo, we're going to do something. And the next copy weirdly isn't for a while, so maybe I don't understand what that copy is. Takes no operands. It depends on row to the matrix using the current values of the state machine. It sets the discriminator register to 0. Oh, because all special opcodes also append to the matrix. I forgot about that. So all special opcodes after this should be. So we get like some sort of like advanced line. What does advanced line do again? Takes a single LEB 120 operand and adds that value to the line register. Okay, then he adds the program counter. Const add PC. I suspect that this is wrong. This felt wrong, right? When we were implementing, we're like, what the fuck is it talking about? And it's kind of jumping us to kind of nonsense spots. But we can kind of assume that, like, based off what this is saying, is that it's supposed to be used in conjunction with the next special op. So these two lines together are supposed to take us somewhere sane. And they are taking us to 837, which doesn't exist. And neither does 621, actually. So my guess is that const add PC is doing something brain dead. Right, because 266, 266, 266, immediately 378. Maybe this advanced line also feels kind of odd. There's a chance there as well. So let's read this again. Takes a single LEB 128 operand as the operation advance and modifies the address and OP index as specified in section 6.2.5081. So we're also kind of making like a big LEB operand as the operation advance. Yeah, so we're doing something fucking. That's wrong, actually. I just read that correctly instead of whatever the fuck I was reading it as before. And okay, so here, what was it? It was advanced PC was the stupid thing. We're calling handle special op, but he said that we're supposed to treat that like operation advance, not like the input here. So this actually should go back to U8. Okay, and then we're gonna say function handle operation function advance operation, and that's gonna take in whatever the fuck this is. Adjusted opcode. This is probably like an any type maybe, because adjusted opcode is a U8 probably, and this is a U8 as well. So we're gonna call this any type. And we're gonna take everything from here, slap that shit in here. This calls self operation advance operation with operation advance. And then in our advanced PC, we call that here with the val. All right. Use the one declared identifier adjusted opcode, which is kind of confusing. Ooh, hold on. So here we're only supposed to be advancing the program counter, not the line. So this is also bad. So this advanced operation, this only gets done in special opcode. In fact, probably all of this stuff also only gets done in special opcode. Right, so this advances the address and OP index, but nothing else. So all of this goes here as well. That feels right to me. Okay. So now, after that advanced line, we go from 265, 265, 265 to 112. Start 2. Maybe reasonable, maybe not. Who knows? So 265 to 112 to 355. So this is standard op, so nothing happens here. Standard op, nothing happens here. This is where the add to matrix is supposed to happen. So 228 is the first, like, reason, like 571 is the first place where we think that we're supposed to be somewhere. And that's broken as fuck again. So we probably are doing something wrong, right? We are definitely getting out of bounds of this file still. So my guess is that this is still wrong. That's my guess, is that advanced line, we're still doing something fucking, not advanced line, hold on. What did we just fix? We fixed advanced program counter, but that doesn't actually change anything. Const add PC, we're probably doing the same fucking mistake. It advances the address and op index registers. Right, so this is actually advanced operation. Right, so we thought that everyone was supposed to be doing like the special op thing, but it was only we weren't actually supposed to change everything. Just the address and op index registers, not the line. We weren't supposed to touch the fucking line. So let's see if we are still getting out of fucking bounds here for sure. So here, let's just double check. Here he is not changing the line numbers at all. And handle special op is only called in this one special scenario now. Okay, so now we should probably look at who's touching state line. This actually, advanced operation no longer has any, this U32 is probably valid now. Yeah. So we can delete this comment. And let's just reread these knowing what we know now. So advanced line takes a single LEB 128 and adds that value to the line register. We forgot to plus again. Fucking dumbasses. Okay, so we are still definitely getting out of bounds on start.zig, but let's just keep going. So advanced line, advanced PC. Let's just look at these again. Advanced line plus equals advanced, and advanced line was supposed to be a signed LEB 128. Okay, advanced PC takes a single unsigned LEB 128 and modifies address and OP index registers. Okay, copy. Adds a row to the matrix and does all this stuff. Okay. Set file takes a single unsigned LEB 128 and stores in the file register. Fine by me. Set column, single unsigned LEB 128 stores in the column register. Sounds good by me. This seems fine. Const add PC is the const add PC takes no operands, it advances address and OP index by the increments corresponding to special opcode 255. So we do that here. Ooh, wait, no, this is wrong still. This is wrong still. We have to do this stuff here and pass in operation advance. You're right. Yes. So 255 here. We pass in operation advance here. I don't think that should change any of these line number outputs, but it does kind of change the program counter stuff. Yeah, so the line numbers are still totally fucked. Also interesting is that I don't really see the address changing much, which is pretty odd. Right? Somewhere we must be changing line instead of address like fucking idiots. Advanced line. Right, that's kind of my read on this. Because here, we're supposed to be printing state address to file name and line number. And like, we're pretty clearly getting stuck in like, you know, why are we at 10349 FF for so fucking long? What happened to the GPU stuff? That's going to be the next project. So it's just we were working on kind of like prepping in happy hour to try to like investigate where we're going to, what we want to. But that's going to come after the debugger. We're going to work on the GPU stuff. And maybe we'll interleave it. I haven't really decided yet. But it's not off the table. Not off the table for sure. Okay, set column. Advanced line. Advanced line. Const add PC. Maybe it does make sense actually to like log when it thinks that we're adding things to the matrix. Maybe. I'm not really sure yet. Like for example here, start.zig 594. Is anything interesting at 594? No. That's not interesting. So 594 is a doozy. So we fucked up sometime before here. 266 is a copy. This is reasonable to us so far. This is reasonable. And then the advanced line to 378, we also thought was reasonable because we're going to POSIX call main and exit. So it's probably these guys. Well, I guess this doesn't have this is a standard op, so this doesn't actually log anything. I'm very skeptical of this const add PC. Very skeptical. Likely address doesn't change because of previous error. Not sure. Not sure that's true. Okay, start.zig 594. So 594 we know is like nothing. What? Maybe that's fine because we set prolog end at 594 is pretty crazy. Does set prolog end add something to the matrix? No. God special op 19. So here 601 is like somewhere where they're trying to log, and yeah, that's if have sigpipe and stood POSIX, so maybe ignore sigpipe. This could be the first line in the function that makes sense. Whereas maybe ignore sigpipe. This is defined at 1035 ACO. And we said that's at 601. So that'd be like here. 10349 FF. So that doesn't feel right. Do we have something at 10349 FF? That would be interesting. No. 10349 DO. Do we have something there? We do have something there. So it looks like this advanced PC is probably doing something fucking stupid because 10349 FF doesn't mean shit to us. That doesn't mean shit to us. So let's look at that again. Advanced PC takes a single unsigned LEB 128 operand as the fucking operation advance and modifies the address and OP index registers as specified in 2651. So this is the address. This is the operation advance, which we have here. Let's double check this logic. New address is address plus instruction advance, which is the minimum instruction length times op index plus operation advance over the maximum operations per instruction. And then op index is op index plus operation advance percent maximum operations per instruction. Okay. Minimum instruction length times this shit. Feels like it's right. Feels like it's right. But I mean, it's pretty clear from the output of this that we are getting something stupid. Well, this advanced line seemed to be reasonable though. So why would we assume that the second advanced line isn't? It's kind of like the advanced line plus the const add PC plus the special op are not working together. Right? And especially const add PC here. Why is this not changing the instruction pointer? Let's look at that again. Const add PC. I mean, there's probably like lots of things stacking up here, but this feels wrong. Okay. So this takes no operands. It advances the address and OP index registers by the increments corresponding to special opcode 255. I mean, that feels like we did the right thing here. Handle special op, right? Because This advances the address and OP index registers by increments. So why would this do nothing? Maybe you aren't changing something by reference. Seems possible. So we are expecting that when we get const add PC, we get this 255, we advance the operation, and we definitely assign these things. So can we like at least look at stud debug print? We got the address incrementing address by this much, op by this much. So instruction advance and new op index minus self state op index, I think is how we want to log this. Okay. So when we got that const add PC, 0, 0 is crazy. 0, 0 feels crazy to me. Right? So like this is like literally useless. Unless we're doing something fucking stupid here. So can we log operation advance as well? Let's look at stud debug print operation advance is equal to operation advance. So operation advance 0. So that also seems fucking stupid. Right? So can we look at what is our opcode base? And line range. Okay. So this is self header opcode base and self header line range. Okay. Okay. So this is 13 over 251. So 255 minus 13. 242 over 251. Which is 0. Right? So I feel like what does this like matrix look like again? Line advance, operation advance. Right, so operation advance is supposed to scale up with value, right? The fact that line range is so large feels like we must have fucked up that logic. But it does say line range here, so adjusted opcode over line range. So we have opcode base is 13, so it gets smaller. Why is our line range so big? Right, this means that our line range can never be like larger than 1. That's like the maximum, which just kind of feels fucking stupid. Oh no, wait. Adjusted opcode over line range. Yeah, because here then operation advance is always going to be like 1. Maybe line range parse incorrectly. Feels kind of reasonable, right? Like this feels like it can't be that big. It can't be, given how it's used here. So can we look at like this header thing? This affects the, okay, can we look at, let's see, maybe we zig build GDB this thing, and then, oh, oops. Fuck. How do I get out of this? Kill GDB, kill all GDB. There we go. I don't want to be piped into less. I think I just fucked up shit for sure. Okay, and then we want to breakpoint maybe when the header is red. And can we look at header? Line base 1, line range 250. Default is statement feels wrong as well, right? This is supposed to be a Boolean. So maybe we've just fucked this up. Unit length? Let's get a little careful here. Header. So version. We start with unit length, which is this like initial field stuff. We saw that we were pretty confident that was right yesterday. Version as a U16. Header length is, we are assuming 32-bit, but maybe that's wrong. So we're going to put this as like suspect. Minimum instruction length, 1 byte, U8. Okay. Maximum operations per instruction. So this is 4, this is 5, U byte. Okay. Default is statement. Shut up. Okay. So default is statement. Then we had line base. Then we had line range. Then we have opcode base. Standard opcode. Yeah, okay. Okay, so we just fucked up the ordering. So can we just do this again? So now, line range 14, opcode base 13, that feels much better. And then we go here, this const add PC goes from D0 to 9E1. 9E1, and then they get the special opcode 228. So F0 to 37, this to this. This is what should get written down. So 9FO to start.zig 378. Okay, start.zig 378. Okay. Object jump. 9FO. Oh, there we go. That's much better. 9FO goes to POSIX, call main and exit, which is correct. Woo! All right. If we go back down to like debuggy now, debuggy looks like it's starting at reasonable addresses. Big win for us, right? We end up at debuggy 482. No, oh, wait, but after advanced line. Okay, so debuggy 23 and then special op. Debuggy 23 from 1034 ECO. 1034 ECO. That's debuggy.main? Okay. Wait, hold on. Sorry. Main. 23? Let's fucking go. Okay, so the first instruction is at the right spot with the right fucking line. That's a huge win for us. That's so sick. Yeah, that's pretty fucking good. I mean, it's kind of hard to see, but like, because this is like a really shitty way of displaying this information. But that's pretty sick. Pretty sick. I know he's crashing at set epilogue begin. Let's see if we can implement that and start. Like, let's just kind of try to finish it out and see if everything else starts to make sense. So we have set epilogue end. Maybe we spelled it wrong. Set ep. Oh, maybe no U in epilogue. No, oh, it's begin. I'm just a dumbass. So this sets epilogue begin to true. Sure. All right. Set epilogue begin. My bad. All right, how's that looking? We are still crashing. I'm not going to pipe this into less anymore. And now we're just like at end sequence. End sequence opcode takes no operands. It sets the end sequence register of a state machine to true and appends a row to the matrix using the current values of the state machine registers. Then it resets the registers to the initial values specified above C622. Whoa, all right. All right. That's crazy. So where is this end sequence called? For the first time here at math.zig 1091. Strange. But we'll allow it. We'll allow it. So we go back. This was extended, I believe. Sorry, end sequence. And here we will say, fix me this adds to matrix and appends a row to the matrix using the current value. Sets the end sequence to true. So self state end sequence equal true. And then appends a row to the matrix using the current values. Then it resets the registers to the initial values above. And so now we guess we probably just need like a reset here. And this is probably, if we're setting everything to the default values, we probably want to do something like we want to say self state is equal to is statement is equal to header default is statement, right? And that's it. And maybe we fix me duplicated within it, maybe. We might want to deduplicate that, but that's okay. And then all we have to do here is just do a self state reset. I guess this is just self reset, which he doesn't like because did I put this on the wrong thing? No. Oh, line program machine. I was a dumbass. There we go. Self header cannot assign to constant, so this has to be mutable. That makes sense. Okay. This got very far now, actually. Through all of Debuggy. Who knows if it's right, but we'll get there when we need to. Special op, got standard op copy, unknown op. Okay, so this feels kind of wrong here. This end sequence goes to built-in Zig at line 1 with address 0x0. That doesn't make any sense to me. That does not make any sense to me. Unless built-in.zig is like somehow linking to some external object that's relocatable. But I don't think it is. It's not a dynamic executable. So everything should be in the exe, which makes this feel very suspect. It makes it seem like this is not doing what it's supposed to do. You know? It makes me feel like this takes no operands. It sets the end sequence register of the state machine to true and appends a row to the matrix using the current values. Then it resets the registers to the initial values specified above. Every line number program sequence must end with a end sequence instruction which creates a new row whose address is that of the byte after the last target machine instruction in the sequence. Okay. Like it almost feels like we were like in the wrong spot. Oh yeah, because here. Oh wait, maybe this means that the program's over. That could mean that. It would be interesting to see where we are. We should know how long the program is by the unit length, I think. And so here we should maybe see if like, we don't have an exit condition right now. So here we should do something like self. Does our reader keep track of himself? It'd be nice if he did. Let's look at fixed buffer reader. fix buffer stream. What's he got now? Pause. So this should be like probably from statement list offset onwards. That's what this should be here. And then here we can check if the reader has gone that amount. Virtual machine to handle bugs. Now this is interesting. Not quite. The problem that we are trying to solve is that we are trying to basically just look up which instructions in like an executable map to which lines in the source file. And in order to do that, we have to implement this virtual machine defined by the DWARF spec to read the debug info. So they have a bunch of like instructions that we've implemented, and it's like this instruction goes to this line, and then add 10 to this line, and then to do all of these things, and then you end up with like a line mapping. It's just this like really weird specialized like language or like machine code that they've specified. Okay, so it looks like we should have a like reader.pause here. Fix me abuse of any type. And here we should check if reader pause. I guess maybe we store the initial position. Whatever. Fix me assumes reader at 0 when passed in, which is actually just not true. That's not true, so we can't assume that. So let's call this like initial end reader pause, we'll call this. And this is going to be like, we're going to pass in the reader here. And we'll just say fix me reader abuse. It's fine by me. And here we're going to say reader pause plus header dot unit length plus however large the unit length one, which I think was 4. Fix me 4 hard coded for elf32 less than 0 FFFFFFFO or something. But we'll come back to that. And then here we can check if the reader pause is greater than or equal to self and self and reader pause, we return false. Because I suspect that we are just at the end of the program. I suspect that that's the case. But we just need a proof of that. Right, because the reader we're passing in is not that. Fuck. Okay, for now, we're gonna undo all of that stuff, and we're gonna track this externally just to kind of hack it. So, fix me need exit condition of LPM. But for now, we'll just say const start pause was FBR pause like this, and then const end pause is equal to FBR dot pause plus header unit length plus 4. Fix me plus 4 is not true for all debugs or all elfs, but now we can at least do if FBR.pause is greater than end pause. Break. All right, let's see what happens if we do that. We still get here, so it'd be interesting to maybe print the FBR, like how much we've read, and maybe we will log the how far we're into it. So not quite there according to the unit length. Can we look at like how we know when it ends in here? end sequence. Takes no operands. It sets the end sequence register of the state machine to true and appends a report of the matrix using the current values. Then it resets the registers to the initial values specified above. Every line program sequence must end with a this, which creates a row whose blah blah blah. It does last, which is whose address is that of the byte after the last target machine instruction of the sequence. So we could actually check at the very least if here we were at BC249. BC24. No, so we were at 10 BC. We are not kind of at the end of the thing, which is maybe not what I would expect. But maybe the other pieces were kind of captured somewhere else. Like, okay, can we just like kind of read this from the top to bottom right now for a second? This 2 and 1 less. So like, what is even happening here? What is even happening here? So they set file, set column, set prolog end. Can we like just print out like this shit? How do I want to handle this? How do I want to handle this? I think I want to change this thing to only output like rows of the matrix. So I guess what I'll do is I'll say while true here. And we'll do something like indent this all, throw this in here. This won't return true here anymore. And we are going to just return when it says we should. So copy, takes no operands, it depends on row of the matrix, then it sets. So we need some way to like output the state. So for now, I'm going to say that this goes next, returns a line program machine, which is going to be a copy of ourselves, just so that this copy can work. So we'll say like const ret is equal to self, and then we return ret like this. I think that's fair. I think that is fair. And then we just have to do this in all of the places where it says we should. So I think that in these special operations, we also have to return. So here we say return self like this. This probably needs some sort of exit condition that we haven't figured out yet. And then else if op equals 0, there was a fix me somewhere. This adds to the matrix. So here we say const ret is equal to self dot star, turn ret. And I think that's all of them. So now we can maybe like understand this a little better. So we'll call this item. And then everywhere we look at LPM before, we replace this with item. Okay. And this is now called next. Okay, let's see what we get now. Maybe this will give us some sort of interesting information. Right, so here we do a bunch of stuff, right? But then immediately here we look at start zig 266. Can we like incrementing address? Can we like replace all this with std log debug? And there, okay. Then I want to turn off the logger essentially. So that will be in DWARF test. We're going to say pub std options equals to std options. And can we just say like log level is equal to std log warn level warn. Here we go. Options. This is cops. Okay. So now we should only see logs of like the actual things that are happening here. Nice. And it would maybe be nice to kind of like just walk through these and see how they feel. So anything that's going to start.zig 0 feels wrong to me. That feels definitely wrong. So it would be interesting to look at what caused that. So we'll put this back to debug. Put it back to debug, and we're looking for start zig : 0. So this was advance line followed by special op 46. Is like line number 0 mean something? It might. It might. Doesn't feel like it should though. They kind of default it to 1. Now the question is, can I do this in Python? Definitely. Definitely this is doable in Python. So this was after. Can we like see kind of the last? Wait, advanced line. Oh yeah, advanced line followed by special op. Special op is supposed to return something. So what was the last thing that was returned before this? Start.zig 382. 383. This is the last thing that was returned before that. Can we look at that in some way? I would like to see. That's fine. We can do this here. Debug info 382. Sorry, start.zig 382. So it feels weird that we would end on start.zig 383. Can we look at like the objdump output again? 34A76. Like this is definitely something that exists in POSIX call main and exit, which goes back to like B5 in, but then there's all this stuff under it. That's like all this stuff. Where does that go? Right? It makes me feel like this advanced line is not doing what it's supposed to do in this scenario. Right? That's kind of what it feels like. But then here, they get 385, which is like a reasonable thing. So they went like here to here, and then they just said, maybe line number 0 just means that it doesn't have. Like if NP optional, yeah, maybe line number 0 could mean that there's not like a reasonable line equivalent in there. I would like to try to read this again. Okay, an unsigned integer indicating the source line. The compiler may have hit the value 0 in cases where an instruction cannot be attributed to any source line. Aha! Okay, so this is at 7.8. 1034 A78. So here they're saying that this move is not associated with any line. And then they go to 7F, which is the instruction after, and they're like, okay, we're at 385 again. Okay, that's fine by me. Fine by me. So we can kind of say that that's probably not the bug. I don't even know what the bug is at this point. I can't remember. But it's okay. So here we kind of see like start.zig kind of like monotonically increasing with some zeros in there. That's fine. He gets to start.zig 482 and EB9, right? So 1034 EB9, which is the end of POSIX call main and exit, which goes to 42 in here, which, oh, wait a second. That doesn't sound right. 476. Oh, probably maybe call main with args here is getting inlined. Oh, because it's an inline function. Yeah, okay. Okay, so this gets inline, so that makes sense. Then he jumps over to debuggy. So let's look at dsphero source debuggy and just kind of trace this and see if this makes sense. So he jumps down to line 23, which is main, which lines up with here. So he goes ECO to line 23. That's great, because that's like we're starting at main, and that's what comes next in the file. He kind of walks through main from line 23 to 28. Okay. Then jumps to 93 in debug.zig. Oh, so he's probably getting like in here. There's probably like stuff in debuggy.main that's kind of like associated with all of that stuff. And then I'm surprised that I don't see a line 30. Oh, I do see a line 30 here. So he goes like D7. Okay, is this monotonically increasing in terms of addresses? It looks like these addresses are always going up. So it's kind of interesting to me that these things are kind of going backwards. But then when you look at how this function is like laid out, it looks actually like the goodbye print is actually like happens earlier in the function. So probably what happens, can we look for, it would be nice if we could see like the fucking addresses that it's printing, but I think that we can probably assume that like the layout of the assembly does something like print this hello, then like do this for loop, and it's probably jumping past the exit condition, right? You see this ret here in the middle of the function, right? So that kind of indicates that it makes sense that here we go forwards, we jump to the end of the function, and then we continue on in this loop after, because this ret is in the middle of the fucking function. At address 1, 4, or F4, sorry, 34 FD4. So 34 FD4 is kind of like in here somewhere, which doesn't actually have this. So probably it's actually the last thing is like FCC, debug zig 95. Oh, so this debug print is probably getting inlined? Is my guess? Or are we just looking at the wrong function here? Am I confused? I'm confused. We're looking at debug print, which is confusing to me. Let's go back to looking at main. Where is the ret in main? That was confusing. I apologize. It's because this window is like moving around. Debuggy.main. Let's try again. Okay, so here's debuggy.main. Here is his ret at EE3. So that lines up, not really. So let's look for, what is that EDE? Here. So this is an add to the stack pointer. This is probably the return goodbye print here at ED7, which we are seeing here, right? And then they're giving another attribution to this line because they're exiting the function. So EDE is probably like, this is the last thing before stack pointer cleanup. Okay. Seems reasonable to me so far. Then he kind of goes through this like do print loop stuff, and then he gets into this like, the next function here is the print, right? So he switches files over here and goes to debug.zig line 93, which I don't have here, but I do have it here, which is a print function. So that's reasonable too. And then this goes into like IO lock. So if we follow this a little bit farther, I wish it was easier to kind of keep all this stuff on the screen at one time. So can we look for like next function? So the next function is weirdly do print loop, which means that this probably after IO and debug.zig probably ends back up in debuggy here. And my guess here is that all of this stuff, this like IO.zig stuff, is getting like inlined here. That's kind of my guess. That's my guess. But then he comes back to debuggy.zig line 12, which is here. And here, do print loop, line 12, address 10350BA. Whoa, well, okay. Oh, sorry, that was debugger.zig. EO. Sorry. So that is, at this point, we have definitely kind of stayed sane, which is very cool, very cool. He kind of walks through debuggy.zig a little bit more, going through lines 12, 13, and 14. So that's kind of all this do print loop stuff. And eventually, we should see him end up at do print loop 2 at address 1035260. So we're going to look for a line 19 here, somewhere in this stuff. Here at 260. So wonderful, wonderful, wonderful. So far, really so good. Then he gets another print function inlined again, so that makes sense. And then there's some built-in stuff. So what's happening at 35440? I mean, oh, this is a default panic, which he is seeing here, which is another good sign. So we can kind of keep scrolling down here. Let's look for the next function start. So we're looking for maybe the next thing to show up after that default panic is at 354BO here. Panic start greater than. Oh, okay, so that's still chilling. Then we are expecting to see an out of bounds and then some TLS stuff at 35530. So that's kind of like here. Okay, TLS stuff, 35530. Looks good. I think for the most part, I don't really want to walk through line by line by line all the way to the end of this because we're kind of at the beginning, like here. Though I think that this looks pretty good overall. Maybe we just check some stuff at the bottom before the last crash. So here, maybe we look at what's going on at like BC249 here, right? So that doesn't exist yet. So that's a little concerning. 10BC2. Can we look for like allocate, like alloc? So I'm concerned about the allocator stuff here at the end. Can we look for like 10BBA40? Okay, so somewhere, it has fucked up. So can we kind of scroll up until we start seeing something that looks silly? I mean, if we slowly scroll up through here, we're kind of seeing everything line up in terms of addresses so far. It's kind of monotonically incrementing. What do we expect to see at the bottom here? We don't expect to go bigger than 1036239. So can we look for like 1036, maybe we look for like a 229 or something. No, 10362. 10362. So we kind of expect our shit to end around here, right? Like here, what function we're in? We're in debug extra and on panic extra at 1036.190. So let's do that at the very least. Okay, so debug.zig 428. This is very much that function. So somewhere between here and like the next huge chunk of shit, we've done something wrong. Right? Because this kind of ends here. So like what's going on with that? Right? So we kind of expect, here he's going debug.zig 428. He ends up down here at debug.zig. He just kind of keeps going. So something, we can maybe like turn back on the debug logs and kind of look for this function and see if we're missing some sort of end condition there. I feel like that would make sense based off of what we've seen so far. So let's go back to debug logs. Let's build and run this thing. And let's just kind of punch in this address again. And kind of see what's around this area that could be causing problems. So 428, 428, 432. 432 doesn't feel like it's supposed to be anything, but maybe. So 432, we're looking at 1EF. 1EF. Is 1EF in here? 1EF is here. it could be that this message is at this address. Move abs 101f 2ed 101f. Well, 101f could be static memory. Could be. Because 101 is like, can we like obj dump read elf dash e? Can we look at like what range would 101f be in? Right, because we're seeing text at 10e something. Oh, 103. So 101 is kind of like in this area. Read only data. Okay, so I actually think that is reasonable, right? 101f does seem to be related to like constant data. So I'm willing to say that that's okay. I'm willing to say that. 10361EF. So I'm willing to say that this, attributing this constant to this load, sure, fuck it. Hey, Srefori, do you prefer to learn by mistake or by deep understand? I mean, I think that those are not necessarily mutually exclusive. What is the best way to learn for you? What way do you think is the good way? Okay, so I think for me is different than for everybody, right? So we'll start there. For you, you will figure out what works for you over time. But for me, I find that you'll notice when watching this stream in particular, you'll notice that we are kind of very loosely referencing spec when we need to, but we're kind of leaning towards like just kind of running it and seeing what happens and then seeing if we can like understand the problems. Because I think for me, when you're saying like by mistake or by deep understand, which language aside, like I think for me, the best way to prove my understanding of something is to like test the failure cases, right? So I go like, I think this thing should happen. Then that thing doesn't happen, and it's like, well, why the fuck not? Something about my mental model is wrong, right? And like we're kind of like probing like the problem space for things that could break our current mental model. And we are definitely missing stuff by doing that, right? This is not as complete of an understanding as like cover to cover reading of something, but it sure makes you understand the problem like at like a core level. Well, I should say me, right? When I hit something, I'm just like, what the fuck? That didn't work. Why didn't it work? And then I like try it and I'm like, oh, this thing was not working over here, which caused this problem. It's like that makes me feel like the knowledge sinks in at like a very core level. Where like if I were to read the spec cover to cover, write it, and then it worked, I feel like a week later I wouldn't remember any of it. But now I'm gonna remember some of the pain, and the pain is memory. So for me, I'm a big fan of just like running at stuff and figuring it out as you go. But I understand that doesn't really work for everybody. Okay. So we end up down here at like 3624. And he's at 437. So what's a 437? A buff print. So if we are at 103624, 1036.264, 1036.264. So that's down here. That's this buff print here. And let's see if we can find a call buff print in here. Panic extra. That kind of matches up with that. Buff print down here at 9F. Oh, yes, there's a lot of stuff getting attributed to this 437 line. So, but like 9F. Oh, fuck. 103629F. Doesn't get attributed at all, actually. Fuck, we kind of lost our spot, huh? We are looking for 1036 to... Here we go. It's somewhere around here. So a lot of this stuff is getting attributed to 437. So what's at like A9 maybe? Like A9 down here is a jump to panic at 437. But there is no... Wait a second. Am I crazy? What is format buff print? He can return a buff print error which has one thing in it, right? So this 437 going to a panic doesn't line up to me. But I mean, again, I guess they're calling set column. Maybe we should log the column number too. That might actually kind of clear some stuff up. Also, we never see you learn a new programming language. We do think you will at some point. I mean, I learned Zig on stream, so that happened. I don't really see I'm not really too interested in programming languages, to be honest. Because I don't really think, like, at this point, like, maybe if I tried, like, a Lisp or something, it would be kind of interesting. But, you know, they're kind of all the same in terms of, like, imperative ones. Okay, so here we're seeing, like, 437, column 37. Column 37, oh, the panic is in this buff. Okay, no, okay, you know what? I take it back. That jumping to panic is in this buff slice deref. Like, this is like a complex statement and I didn't see that. Okay, so this stuff is probably still fine. Why did I think that this was the end of the file? I don't know why I thought that. Can we go to like 10D7620 or something? 10D76. Not found? Oh, was it because like... Yeah, wait, am I high? 10BC? I thought that like 10BC was not found in here at all. What? But I'm just stupid. 10BC 12. 10BC 129 is going to allocator.zig. So what is going on? Sure, seems fine. I don't know why I was like lost. Like, but that's okay. So this guy's kind of just like in allocator.zig shit. He kind of gets all the way down here to like 10BC 10BC 21. Oh. Kind of gets all the way down here and then kind of like says, okay, we're fucked now. So this is an allocator aligned alloc, and what comes after this? Okay, wait. No, that makes sense. So he kind of finishes the allocator stuff, and it looks like probably here, this built-in .zig shit is supposed to line up with stuff like this. Hold on. Was nothing wrong here? It could be that this is just a different built-in .zig. Can we look for like the definition of like CLZ SI2? This is in CLZ SI2. Where is this like defined? Function. Okay, CLZ SI2 comes from compiler runtime count 0 bits zig, which is kind of confusing. So it kind of looks like we kind of went through this whole disaster of just like reading instructions like that for a while to kind of get to the point where it's like, oh wait, maybe that end sequence does make sense. Maybe it does. And it's like, now why do we not see this stuff? Maybe because this stuff doesn't have, maybe compiler runtime? Compiler runtime's a fucking different file. Compiler runtime's a different file. Oh, wait. We were looking at, when we were looking for our exit condition, we were looking at the size of the whole fucking section. Oh my god, I'm so stupid. Wait, okay. Hold on, I think we got there. So this is like debug line. Oh, never mind. Wait, maybe I take this back. This is supposed to have like compiler runtime as like one translation unit or compilation unit. And then this is like debuggy and plus imports, right? So this end sequence, this got hit right at the boundary in our executable of where our file and like the compilation unit for debuggy and the compilation unit for compiler runtime hit each other. So that's actually really good. Now the question I have to ask is like, why the fuck does it think it's not done yet? Right? Because I was looking at unit length here. So we get to the beginning of this thing and we go like, how long do we expect this section of the binary to be? I wonder if it's unit length plus header length. There's like a good chance that's the answer. So let's double check here. So when we read the header of this section, this is the size in bytes of the line number information for this compilation unit, not including the unit length field itself. Okay. And our reader is assigned from the beginning of the thing. So I'm back to being confused. Maybe there's just like extra padding on the DWARF info of stuff that like we don't. Because it really does seem like they did say that the end sequence here, end sequence register, is like we're fucking donezo. Which is what we are seeing actually. We are seeing that we are hitting this end sequence at the very end of the compilation unit. So then the question becomes, why? Why is the unit length wrong? Can we look at maybe the header length here? The number of bytes following the header length field to the beginning of the first byte of the line number program itself. Is there like a program length? Opcode base standard include directories file names. Okay, no. Not including the unit length field itself. My gut is saying here, reader. No, this doesn't make sense. The unit length is the size of the line of information for the compilation unit. If somehow, hear me out. If somehow, this is wrong. This is wrong. I'm an idiot. This is wrong. This is the unit length from the start of the reader, including reading the header. So let's try that. Let's try that. Oh, there we go. We fucking broke it at the right point. Let's fucking go, baby. Okay, so I think that we parsed the whole program, and actually all of the lookups seem sane to me, which makes me think that our really shitty virtual machine is right. Which is kind of fun. For sure. So, yeah, what do we do? This thing has all of these parameters that we don't really understand what they are yet. I think that we have a pretty good idea of what file, line, and column are, which is kind of like the most interesting part. Is statement was definitely related to like, should you set a breakpoint here? I don't really know what all of this stuff is, but it sounds like this is like stuff that your debugger might kind of want. This is stuff that like everything in here could be a parameter in your matrix that you're making. But yeah, it feels like it's working. I was going to, if we finish this stuff really early, kind of implement like breakpoint by line or something. But I think I might leave that up to as like a part of draw the rest of the fucking owl. Maybe we'll do that in happy hour or something. I don't think it's worth its own stream. Because I think we have all the information we need now to do that. Pretty stoked on that. Lots of like error conditions to handle. Lots of like, we're kind of only parsed one binary now. So there's not really a guarantee that all binaries will be like this one, right? But we're probably missing some instruction implementations, but whatever. I'm happy with that. I think that was a fun little stream. I feel like I understand something better. Maybe not something of value, right? Who fucking cares, right? Is a reasonable question. But, you know, now next time you set a breakpoint and you're like, why the fuck did it move the red dot like 3 lines back? now we kind of have you could kind of reason about that. We go, well, probably the program that came into this thing probably had is statement on a couple lines back. Or if you're like, what line is this instruction? Like if you have like, where the fuck am I? In GDB, if you're stepping by instruction, and he's like, I don't fucking know. Well, then we know, well, we've seen some cases where this program constructed a line value of 0, which means it can't really be attributed to any line. So maybe we can attribute to the line before, but like that wouldn't really be accurate. So there's now like behaviors that we can observe that we can maybe reason about a little better, which is pretty fun. All right. Pretty happy with that. Thanks for watching, you guys. If you like what you saw, we stream most days at around 12:30 o'clock Pacific time to 4 o'clock Pacific time. The schedule for the past few days has been a little bit off. I'm hoping to get back on track soon. Tomorrow there will probably be no stream, and I'll probably be back on Monday, and I have to decide what is next. We'll see. I'll let you guys know on Discord. If you're watching on Twitch, there's a YouTube link in the Twitch description. You can check out previous projects or this project organized into playlists if you want to check that out. There's some stuff in there. There's a GitHub link in the Twitch description where code for this will eventually end up over this DSphero project. If you're watching on YouTube, swing by on Twitch if you're online between 12:30 and 4 Pacific time. And if you want to see the kind of supplemental happy hour content, you can join on YouTube or on Patreon to get archives of those sections of the Twitch VODs. Otherwise, like, subscribe to Twitch Prime. You guys know the dealio. And let's say bye to YouTube and Twitch. Let's find someone to raid.